Okay, so guys, welcome to the first video. Here we're going to talk about the basic syntax, how to start your first code, and all the basic syntax including the cin, cout features and the if-else statements. So when starting a new C++ file, first always you got to include a library, include IOStream, right? Keep in mind, to include a library we use the hash function, we use the word include, and we use the greater than and less than signs, and in between we write this library. The IOStream library allows us to output and input data into our code. It helps us in these normal functions. That's why we always include it. Then we write using namespace std. std, this allows us to omit std in our code. If we don't write this line, after every cout or cin feature of this library, we would have to write std cout like that. So the issue is rewriting this again and again is really a headache. So what we do is we simply write using namespace std. Now we don't need to write stds ourselves, the compiler is going to do that for you. Then we are going to write int main, bracket open bracket close, parenthesis open parenthesis close, and return 0. Even if you don't want to return 0, you can remove it, but it's better you write it. In line number 6, from here on we are going to write our code, right? This is where your main code is going to run. This is the basic boilerplate for a C++ code. Before you write your code, you gotta put these lines in. Now you can start writing your code. Your code which needs to be executed comes in the main function. Well, and if you want to make your own functions, they are going to come above the main. You can also put them below the main, but you need to declare them above the main. We are going to come onto the functions after a little while. Let's first start with basic code. To output in C++, you got to use the word cout and two less than signs, and you're going to write hello world. That's what everyone writes as the first code. Keep in mind, this is a string, right? Strings are chains of letters. It's a sentence. They are known as strings. I assume you already know such things, as here we are going to be on the basics and we are going to move on to the logic building. So writing cout allows you to display on the terminal. If you press these four squares, as I told you in the first lecture, this will run our code and we are going to get our output shortly. Right, so once you have compiled it, you press this, the third option, which compiles and runs your code. As you can see, we get our hello world. It is the third option from here, right? Okay, so cout is used to output whatever you want. Suppose I write a math equation 3 plus 7, an expression. If I run my code, it automatically first calculates it and then outputs it. Keep in mind, I did not use these colons in this case because these were not characters. If I use these speech marks, what is going to happen is, now it's going to think this is a text and it is simply going to output 3 plus 7 because it thought this is this is a sentence. So that's why it did not calculate it and it directly outputted it, because it thought this was a string. If you write it directly, it is going to first calculate it and then it's going to output it. Okay, similarly, let's start with variables. Variables is a place where you can store your data. Now if I, for example, you know what an integer is. It's a number. So if I write int, in C++ we use the word int. int number. Number is the name of our variable. We can name it anything we want. You can name it test, you can name it num1, you can name it any number, whatever you would like to name it. I would like to name it number. In this, suppose I store the value 5, int number equals to 5. Now if I see out, I can see out the variable. What it's going to do, it's going to call the variable and it's going to call the data stored in the variable, and it is going to output the data. Now if I run this, and you can see it outputs 5, because whatever is stored in the variable, it is outputted. Suppose I change this number into a string. I write string. Suppose I write string and I write let's just say str1, and I save in here Zafir, my name. And if I try to output str1 now, I get Zafir, because now str1 stores a string. But suppose I write int over here. Int means that this variable is going to store an integer value, but I have given it a string. Now you're going to see an error. This error says invalid conversion from constant character to int, meaning you cannot store a string into an integer variable. Okay, now for variables, you can have an integer variable. Let me name it I am integer, right, which can have any integer value of your choice. You can have string variable, I am string. Okay, your variables cannot have spaces, it cannot have some special characters. It should always be one string. So string I am string, and it can have my name. You can have character variable. Char is the short form for character. So I am character. Characters store only one character, and they are denoted by a single speech mark. Okay, you can have float variables. I am float. Float variables are actually decimal numbers, 2.34. Keep in mind, you cannot store decimal numbers in integer. Absolutely not. It is going to just give you the whole number. But in float variables, you can store decimal numbers. Similarly, there is one known as double. I am double. Double can store a higher range of decimal numbers. It has a bigger limit, right? So these are the variables. Oh yes, and you also have bool. Bool is the short form for boolean. I am boolean. Boolean can have only two values. It can either be true, or it can either be false. You can either write true or false, or you can write 0 for false and 1 for true. But we usually use true and false for boolean values. So these are the most variables we are going to use, and these are the mainly one you are going to encounter during your C++ journey. Let me give you an example. Suppose I have an integer variable name as num1, and I try to store a decimal number in it, 2.34 suppose. Now let me see out num1, which is an integer, and it should technically not store a decimal value. And if you see, you only get the 2. The decimal is dropped off since it was flagged as integer. But now if I write float for num1, and if I try to see it out now you can see you get the whole decimal to yourself. So this was the variables part of C++. Moving on now to some arithmetic symbols. If I tell you this is plus, simply if you want to add something into something, or you want to subtract, you use the minus. For multiply, you use the star, which is on your number 8, and for divide you are going to use the slash. So suppose if I make an integer a variable calculation with the name of calculation, and I store in it 4 divided by 2, and I see out calculation, I'm going to get 2, because 4 divided by 2 is 2. It is first going to calculate it and going to put it in the calculation bar. Suppose I do 5 divided by 2. The answer should be 2.5, but since this is an integer, it is going to drop the decimal. And as you can see, you only get the 2, the 0.5 is totally dropped. But if I make it into a float variable or a double variable, sorry, you need to write it 5.0 and 2.0. I'll tell you in a bit as to why. As you can see, 2.5. The thing is, when you expect a decimal answer, you need to give a decimal input. First, we had constant numbers. We only had 5 and 2. These are integer numbers. 5 and 2 are integer numbers. Hence, the output was also given automatically as an integer. In C++, if you expect a decimal output, your inputs should be decimal. Even though they are whole numbers, we need to make them decimal inputs. So now if you see, I get a decimal answer because the values input were decimal. So keep this in mind. Moving on to control statements. We are now starting with control statements. In control statements, you have the if statement. Suppose, let me first give you an example. We have an integer num1 which is 4. If num1 equals to 4, okay, this equals to is the comparing operator. What it does, the equals to will compare the value of num1 and 4. If same, it returns true, else it returns false. So it is going to compare if num1 equals to 4. This will be wrong because I put speech marks on the number 4. So it is going to expect that num1 is a string. We are going to simply write 4. We are going to remove the speech marks as we are talking about integer numbers, and integer numbers don't need speech marks. So it is going to check if num1 is same to 4. If it is same, the code between these two parentheses are going to run. So here I'm going to see out yes, they are same. Keep in mind, every sentence needs to end with this colon, semicolon. So now let's run our code. As you can see, yes, they are same displays. If I change the value of num1 to 5, we won't get any output because we haven't told it what to do if this statement is false. Now let's use the else statement. Else statement means if this statement is false, always run this statement. Since our first statement was false, I would like to output no, wrong. Right? So let's try this. As you can see over here, it outputs no, wrong, as that is what we put it in the else statement. We can also use an else if statement, which means if the first statement is false, and then go and check the second statement. Else if num1 equals to 5, then see out it is 5. We can also add numerous else if, but only one else, because if everything fails, then we can go to the else. And in the else we can write see out it's wrong. As you can see, the output we get is it is 5. Why? Because our else if statement gets true, because num1 is equals to 5. If we put it back to 4, you can see we get yes, they are same, because that's what we put in the first if. And if I put in over here 6, we move towards the else, which says it is wrong. As you can see over here, we output it is wrong. These are the pretty simple control structures which we will be using. If else statements are used a lot. Now we move on to loops. Okay, now coming to loops, the first loop we are going to use is the for loop. For the syntax of for is going to be for int I equals to 0. I is less than whatever number you want to say. Suppose I say 100, so it's going to run 100 times, and I plus plus. What the syntax tell is make a new variable named I. You can change it to any letter or any word you want. We usually use I. For int I equals to 0, we start from 0, right? I is going to loop until it is less than 100. Once it goes over 100, it's going to stop. And I plus plus. In every loop, we increment I. The plus plus sign means plus 1 in each loop. So in each loop, I is plus by 1 and keeps moving forward, right? So in this for loop, you can do anything you want. I write out cout hello and endl. What endl does, it changes the line to the new line. Now if you run this, you're going to see hello 100 times. This is 100 times. Why? Because the loop was for 100 times. Let's take it to a normal value of 10, and if you run this now, this is 1 2 3 4 5 6 7 8 9 and 10. This is now hello outputted 10 times. This is what loops does. This is a very basic input to loops in intro to loops, but we are going to delve into more complex situations of loop in future videos. Similarly, we do have the while loop. While loop is pretty simple. While whatever statement we give is true, it keeps running. For this, I make a variable int counter equals to 0. While counter is not equal to 10. Keep in mind, exclamation mark and equals to means not equal, right? Right? So this means not equal. So we say while the counter is not equal to 10, do whatever I'm writing inside. I'm going to write inside cout this is running. Now if I directly run this code, there's going to be an issue. You're gonna see it run in till infinity. If you can see, it's still running, it's still running, and it's still running. Why? Because the counter was always set to 0, and this statement never became true. It never became true, so our while loop kept on constantly running. So keep in mind, whatever statement you give in this while loop, you gotta change the variable too. So now in every while loop, what I'm going to do, I'm going to increase the counter by 1. So we can either write counter plus plus, as I told you, plus plus increments by 1, or if you want, you can write plus equals to 1. The plus equals to means to add to the variable whatever value we write after. So over here I write 1, so the counter will be added by 1 in every loop. If I write over here 2, the counter would have been added twice in every loop. So this is the second way. Whichever way you feel convenient, you can use. If you can see now, our program is not running infinitely, and it has stopped, and it has stopped on 1 2 3 4 5 6 7 8 9 and 10. So it has run 10 times. This was the while loop, and this was a quick refresher of the basic C++ codes and this C++ statements for this logic development series. Rest of the things, such as the break statements, such as switch cases, you might tell when we are writing our own code or in some future videos where we need it. But these were the main things I wanted to go over before we start going into the logic processes and logical questions, because these were the main things which we will be using and we will be going to attach together, and they're going to be running simultaneously. So yes, if there are some things in your mind, you can comment on them. You can comment and tell us. But these were the main logic which you need to have before we start our logic building course.